Hi, everyone. Just to introduce myself quickly, my name is Robbie, as you've heard. I'm a senior data and AI consultant based in Singapore. Previously, I was based in Thorogood's London office, and I'm the managing director of our Thorogood Singapore office. I've been delivering data and AI solutions for customers in Asia and Europe across different industries such as consumer goods, medical devices, and pharmaceuticals and insurance as well, which hopefully gives me a bit of experience to talk about how to set up your data platform and data engineering processes in the right way. And really, that's the message I want to get across today is that in order to solve data inefficiency and set up for long-term success, organizations require doing many different things correctly. But really, what we see as the most central aspect of that is setting up your data platform and your data engineering in the right way. Not all data platforms are equal, and we've seen that many organizations don't have their data platform set up for success. So what we're going to do is we're going to talk through how you can recognize some of those indicators of how a data platform isn't meeting your needs. And then we're going to cover what are the things you need to consider when you're setting up a new data platform or when you're reworking your current data platform to try and be successful in the future. And we're going to share details on how we've implemented optimal data platforms for our customers that have met the needs of their business and their organization. Let me start with recognizing the indicators. So what we found whenever we've worked with organizations where they have their data platform already set up, but it's not quite meeting their needs, we've seen a few sort of common indicators that show why it's not working. So one is companies that are having to recreate new data flows every time they're running a new data and AI project, every time they're bringing in a new data source. They're having to recreate something from scratch rather than build on what's already there. Additionally, we found that there's substantial red tape that slows the, say, addition of new data to the platform. We found that whenever the business has a lot of drive to move forward and go through quickly and provide input into what data needs to be brought into a data platform and how it needs to be formatted, they have to go through needlessly long IT requests to actually get anything moving in the data platform. We found data platforms where, in order for everything to work day to day, you have people actually spending too much time performing manual tasks to help the platform run when really all of that could be automated. Additionally, we've seen data platforms where, in terms of the end user data, the end users, the business users who are actually using that data are spending a lot of time wrangling it to get it in the format that they need, rather than actually just getting the data in the format they need so they can explore insights and identify new business value. We've also found unnecessary lag time between when latest data becomes available in source and when it gets into the hands of the business. And finally, we've seen cases where the data and IT team who are managing the data platform don't really understand the goals of the business, and the business don't really understand the constraints that the data and IT team are under as well. So if any of these indicators are true for you, how can you set the foundations to build your data platform in the right way? Well, what I've got is a whole list of considerations and some subpoints around each of them as well. So what you should consider is the wider potential of your data platform rather than just the current requirement. So your current requirement may be to bring sales and finance data into a data platform and report on it. And you could build a platform that will do exactly that and do it very well. But if you want to build a data platform for future success, you need to be thinking about what are the future data sources that might come in: supply chain, HR data, manufacturing, telemetry data, any number of different data sources. You also need to think about what are the different uses of the existing data and how it may be used in the future. So throughout all that, you need to manage the costs for now and the costs for the future, and you need to make sure that whatever you build in the future is going to deliver information fast to those who need it. And you need to be able to build it in a way that's going to accommodate future changes in technology. One such change that's come along is AI. And whenever you're building a new data platform, you now need to be considering how to accommodate AI potential. One big example is, will AI understand the contents of my tables and fields? So increasingly, we've worked with a lot of customers to use AI either in their data engineering processes or in sort of end user self-service of data. And for AI to be able to go into your data and query the right data and provide the right answer to the end user, your tables and field names need to make sense. It's fine if they make sense to your team, but would they make sense to someone coming in completely new? Is everything labeled correctly? That's going to be really important for AI applications to be successful. Additionally, with the whole movement of AI, suddenly all of this sort of unstructured data is now readily available and ready to sort of glean insights from. And you need to work out, how can our data platform handle unstructured data sources and not just all your sort of rows and columns of structured data. Next, you need to consider business engagement and ownership. So, who in the business holds the knowledge? How can they share it with the people who are actually going to have to bring the data through and apply that business logic? And additionally, do the business have any appetite to handle some of that themselves within the data platform as well? Then you also need to consider, what are the insights that are going to be valuable to the business? So, what is the analysis that business teams are already doing that you can improve with your data platform? What are the new areas that your data platform could help the business analyze? And what's going to be the goal of that analysis? Is it to improve efficiency? Is it to find root cause issues? Is it to find untapped opportunity? Is it all three? Is it even more? An awareness of that really helps shape how you build up your data platform. And then finally, just in terms of how easy it is to maintain the solution and set up the team well for further development or to support the existing data platform, you should be thinking, how easily can someone new come along and be onboarded to help manage our data platform? Are they going to know where to go whenever a sort of brand new issue comes up, say in data quality in a specific table? How quickly are they going to be able to come on board and understand that? And what skills are they going to need to have or develop to help maintain this solution? So obviously, that's a wide range of things to consider. So let me share a couple of examples around how we think of a data platform and how we can address some of these considerations. So, for example, this is what a sort of very high level view of a data platform looks like. You have your source systems, you ingest your data from source into the data platform, you curate it, you're sort of cleansing it and transforming it, you serve it up using a database tool where reporting tools can then come and access it. And what we've seen in a lot of sort of more poorly designed data platforms is that the logic can be done in any of these layers. But what we've seen in bad ones is that it's done across them all, and that needs sort of a mix of skills and an understanding of what's happening in every layer to understand where you can fix issues and where you can bring in new data. It makes it very hard to maintain. It's not very good in terms of ease of maintenance or ease of further development. So what we would recommend is trying to concentrate transformation logic as much as possible into one single area, so that whenever there is a data issue and someone in your team is trying to look to see what the issue is and where they can fix it, they know they go here to make that change and make that fix. Additionally, if you're bringing in new data, there's no question around sort of, okay, where are we going to do the transformation logic? You know, it's going to happen in this set layer. That's where we're going to cleanse and transform our data. The rest is just going to be sort of relatively simple data copies. And basically, your goal is to minimize the number of tools being used, reduce the amount of learning needs from the people who manage the data platform, make those sort of design challenges easier and more understandable. And as I said, just create easier support and maintenance. So that's one example of how you can help make something more future-proof by making it more simple to maintain. One caveat I will give to that is that by the time you're getting to reporting tools and you have different teams with different KPIs and different things they want to report on, we do appreciate that you might need some logic in your reports to have sort of very application-specific data transformations and formulas and stuff like that. But generally, try and keep the transformations isolated into as few places as possible, so it's easy for overall maintenance and future development of the platform as well. Another way we set up data platforms at Thorogood for our customers to be future-proof and easy to bring in more and more data into is by setting up a metadata-driven data platform. So what I've put together here is a bit of a sort of more detailed data flow across the data platform all the way from source to reporting. And it's actually based on a very similar approach we used for an aerospace manufacturing company as well as a insurance company. The insurance company used Databricks to move their data through. The aerospace manufacturer used Fabric to move their data through the layers. But really, whether you're using either of these tools or any other tool, the best way you can sort of manage the data flow from source to reporting is to set up an overall framework control, what we call a metadata-driven data platform. And to explain what that is and how it works, what we will do is we'll basically set up as few pipelines as possible, ideally just one single pipeline, but make it highly parameterized so that all we need to do is query a table to get the particular pieces of information we need to load through particular sources of information. So, for example, for moving data from the bronze layer to the silver layer, we can just go and query to find out what format do we need to load the data in, what format do we need to load the data out, what's the path we need to follow to get that data, what's the path we need to follow in terms of where we're writing that data, and then this can contain all other sorts of things, more locations, more formats, and then additionally some of the sort of transformations you want to apply on particular sets of your data as well. And the beauty about this is you're not having a brand new data pipeline for each of the new data sources that you're trying to bring in. Instead, you have one, and when you're trying to bring in a new data source, you just need to add a new row, fill in all the details, and it should follow the same flow all the way through, listening to the different parameters that it has to call. So that's the value of a metadata-driven framework. We would do a similar approach for our data quality checks and our overall data testing as well. All of that is held within the sort of framework control, where we're also writing out some of our logs around the transformations and things that have been successfully completed or have an issue with them that we need to rectify. And then additionally, within that framework control, that's what we can use to notify people when their data has been loaded through. So just a way you can make your platform really scalable and really easy to maintain is by managing everything through metadata as much as possible. So that's one aspect in terms of how you set up for long-term success with key data platform and data engineering. And what you've probably heard a lot is that sort of foundation is key to building successful AI applications. I wanted to give an example of a couple places where that's been the case, as well as talk about the sort of additional bits of data engineering that we need to do on top of that. So, for example, we worked with Apollo Underwriting, which is an insurance customer. And at the time when we were speaking with them, we'd set up a data platform with them. They were getting all the data they needed in terms of structured data. But in terms of dealing with things like claims, they were receiving an awful lot of unstructured data. So they were receiving around any claim, they could get like maybe up to 30 documents with emails, first notice of loss, different lawyers' documents, invoices, loss adjuster reports, and it could all come in many different file formats. And what they had to do was take out all the key little pieces of information from each of those documents to form one sort of structured one row view of the claim that's being made and whether they can approve it or not. So to give an example, you would have things like loss adjuster reports. Like, for example, this loss adjuster report tells us that if you look at the second line, Trevor's insured, Trevor's the claimant, and the claim amount is 200,000. For the same claim, they might also have the first notice of loss, which tells them Trevor and his policy dates and the date of his loss and the cause of his loss. And that's key information that we need to bring in. And there may also be emails back and forth, which actually tells you the claim amount being made. But what you can see is it's slightly different here to the loss adjuster report. And what they were doing was they had a team that would manually look at all these documents and work out, okay, the loss adjuster report is a better source of truth than the email. So we're going to go with that. And we're going to get the sort of cause of loss and date of loss information from the first notice of loss overall to get a picture of Trevor, his policy dates, his date of loss, cause of loss, and the claim amount as well. But all of this was being done manually. So what we were able to do with our data platform was bring in the sort of unstructured data that we need and do further data engineering on top of that to actually pass the right data sources to AI. So, for example, we were able to get the claims documents, run them through Azure Document Intelligence, extract that text into JSON format, then pass that extracted text to the classification model, so the large language model, which then classified the document type as an email, first notice of loss, loss adjuster report, etc. Then pass that classification and the JSON extracted text to the field extraction model, which would basically say, for this type of document, look for these pieces of information. And then we would collect all of that information from all the documents together and apply a set of rules in a sort of data engineering process to pick the key bits of information that we need. And then we would write that output back to our data platform, where it can then be viewed via tools like Excel and Power BI. So just one case here of where having a data platform, strong data platform, is able to help, particularly for some of these more niche applications that involve AI, but also there's going to be little bits of data engineering involved in the sort of AI solution as well. Another example of that is with a global consumer goods company, where the company had dashboards that answered thousands of different business questions. But despite having this great sort of library of dashboards, they were still finding cases where someone was trying to answer a particular business question, didn't know a dashboard existed, and therefore would go and extract text and do their own data analysis, really. And it would take them, a few hours or a few days, depending on the nature of what they're trying to do. And then they would find out later that a dashboard existed and they could have got the answer in 1 minute. So what we did was we worked with them to build an AI application that allowed them to ask that particular business question. For example, what are the top drivers of profit change for retailers? And then they would receive the dashboards that were most likely to answer their question, along with a sort of percentage confidence in terms of how confident the AI model was that this dashboard would answer their question. And this may sound like, okay, we loaded our data into a data platform, put it into Power BI, and then we just pointed it at AI, and that was able to match up the user's question. What was really the case was we had to use our data platform and particular data engineering techniques to be able to extract the information from the dashboards to understand what types of questions it would answer. So we had to use REST APIs to automate the extraction from hundreds of dashboards, including the names, URLs, screenshots of all the different pages of the dashboard, what filters were applied, collect the usage analytics as well, provide it to the dashboard owner to review it and provide more context, and then pass it to a large language model that would then provide a description of the dashboard and a list of questions that the dashboard answered based on like the dashboard images, the descriptions from the dashboard owner as well. So it took bits of data engineering to collect things like those screenshots, pass it to the right person for review, and then pass it to AI. So even when you're talking about an AI application, there is going to be little bits of data engineering that's going to be really important. And having a data platform set up that can help you handle that is absolutely key. So what are my key takeaways from the session that I've just taken you through? The first is you want to implement a data platform for future success, not just for the current requirements. You want to implement smart systems like that metadata-driven platform that allows you to be flexible and scalable and add new data easily and deal with new data quality issues and make it easy to fix those. You want to not just design that and build it once and forget about it. You're going to need to regularly step back, take stock, and check, is this data platform giving me what I need as a business? And also check, is there sort of new latest technology that can be added to this to improve it or improve the outputs that we're getting? Third, it's really vital that you build a close collaboration between the business teams and the IT teams, between those managing the data platform and those using the data platform. The more the business can understand what the limitations are of the data platform, and the more the IT team can understand what the business really want from it, the better the results are going to be in terms of driving business value from data. And then finally, just a reminder really that successful AI applications rely on a strong data platform as well as proficient data engineering so that you're passing the right things to these AI models and they're going to give you the right types of output as well. So with that, how can Thorogood help you? Well, just to give a little bit of background for those who don't know Thorogood, we are a global independent data and AI consultancy. And the majority of what we do is end-to-end data solution delivery. So building these types of data platforms, bringing data through them and putting the right data in the hands of the business. And our skill really lies in the overlap of technology, data, and business. And basically, how can technology and data hand in hand help drive and meet your company's business goals? So what we can do is use a lot of that skill and our knowledge of technology to help you and advise on your data platform. Our knowledge and technology spans across the 3 leading cloud vendors, Microsoft Azure, AWS, and Google Cloud. We're also a Databricks Brick Builder solution partner, and we work with a number of other technologies as well. So technologies that you may already be working with will understand, as well as technologies that you might be looking to work with in the future. And then how can our Thorogood team help further? Well, if you are looking to, say, build a new data platform or rebuild your current platform, but in a more efficient way with better future success, you can talk to our consultants. So if you know any of our consultants already, please feel free to reach out to them. If not, please feel free to reach out to me, robbie.shaw@thorogood.com. You can also go to our thorogood.com/perspectives page to be able to see sort of previous webcasts where there's somewhere we've given a lot more detail on sort of the metadata-driven data platform framework. And there's all number of other topics that we've covered as well. So it's a great wealth of knowledge if you're looking to sort of understand what we do more and our perspective on how to build good data and AI solutions. And then finally, go to thorogood.com/events to see our upcoming events. I think most of them are virtual, so you can look at those, such as this webcast. And with that, I'll leave the QR codes up on screen. But thank you for joining. And any questions at all, please feel free to reach out to me on email, robbie.shaw@thorogood.com, or on LinkedIn as well. Very happy to take any of your questions. But with that, thanks everyone for joining and have a great day.